Hi, welcome to the August 9th meeting of the CNCF IoT Edge Working Group. On the agenda today, we're going to open with a presentation on wasmCloud as it relates to Edge. Then, assuming there's time remaining, we also have an item on the agenda to discuss the Edge native white paper and promotion of it at the upcoming KubeCon North America. So with that said, I made you co-host, Liam. I'll let you introduce yourself and just take over.
Great. Hello, everyone. My name is Liam Randal. I think I know most of the people on this call at some level. And today I'm going to be introducing CNCF wasmCloud and also talking about WebAssembly and some of the neat use cases we see around our ecosystem. Just a quick little about me. So I've been in the cloud native ecosystem since 2014 when we kicked off with Kubernetes. I actually launched the very first Kubernetes company. It was a company called Critical Stack, which I sold to Capital One, where I helped to work with an amazing team to create other CNCF projects like Cloud Custodian and help to move a big bank into the cloud. I love WebAssembly, and I genuinely think that it's the next epic of tech, and I'll try to make that argument here today. But I would ask that everyone on this call feel free to raise your hand, ask questions, interrupt. I'm here to help communicate, not just to speak at you. So I've got a ton of information to run through, so let's go ahead and get started. If you think about the last epics of tech, there's this pattern that we see of continued higher abstractions, where everyone looks around and says, what's the common complexity? Let's make that the platform and build up from there. And from where we are with containers today, there's still a ton of common complexity. And this was what originally drew me to WebAssembly, was simplifying the ecosystem and the lifecycle for the management of applications. And early on in the WebAssembly journey, we saw this opportunity to start driving those sorts of patterns. So what is WebAssembly? So WebAssembly has actually been around for over a decade now. It started with what some people call the greatest software hack of all time. Alon Zakai, I had this crazy idea of what if we could take modern languages like C++ and transpile it to JavaScript. And boom, we're running Doom in the browser. And since then, a number of standards bodies have spun up, but WebAssembly is actually standardized by the W3C as the fourth language for the web. And it's really a compilation target. These are the members of the Bytecode Alliance, which is an organization that builds and helps to run WebAssembly. Now, if you're new to WebAssembly, it starts as with first principles, but it's neither web nor assembly. It is a compilation target. And I think the best way to think about it is as a little tiny virtual machine that takes numbers in and numbers out. And that's it. It's a little CPU with no operating system, no standards, and it runs everywhere. You're already using it today. As we get into the presentation, I'll try to highlight some neat use cases. But it runs inside of browsers. It runs inside of runtimes for servers. And it can be embedded into other applications. So it's been adopted all over the CNCF as the sort of FAS runtime of choice. It's safe and secure. It gives you little tiny limited memory space. It's pretty performant. And it is a polyglot. So you can actually bring multiple languages down to it. Now, really underneath the hood, WebAssembly has some challenges because it's just three integers, a bunch of integers in a trench coat. It's not really all that complex underneath the hood. It doesn't have support for structs or ASCII, large data types that we would expect to see. So there is some challenges that you need to lift and lower things into WebAssembly. But what is really powerful is that it runs everywhere. So organizations like Amazon Prime Video use WebAssembly to deliver their primary app. It allows them to iterate faster. It allows them to increase the performance of their applications without deploying a full kit of firmware to over 8,000 unique devices. WebAssembly is adopted in places like Shopify as a configuration runtime for Envoy and Istio. So it's really got a ton of options because it lets you give developers choice of languages that they start with. And it's performant, and it runs seamlessly across different architectures and operating systems. It was designed for the web. If it sounds familiar, think of what Flash aspired to do or what Java aspired to do in the browser, but now is a W3C standard and not controlled by a single company. And this vision of supporting multiple languages means that all of the various silos that we have today around our company of frameworks and libraries, it gives us an opportunity to start thinking about how we might take all of these disparate languages and suddenly build applications out of composable Lego blocks. And this is where runtime, an application runtime, like CNCF wasmCloud comes into play. So what wasmCloud aims to do is to give you a great developer experience around adopting and running WebAssembly in your organization. And there's a lot of great open source and other runtimes that are around, but this one is in the CNCF, and it's got around 150 contributing companies, including big banks, defense contractors, automotive companies, and lots of other organizations. And it actually leverages a ton of common standards like OpenTelemetry, CNCF NATs, cloud events, and Open Application Manifest in order to sort of deliver a unified experience that's familiar to users in the CNCF, but certainly extends the ecosystem. There's a separate, if you go to wasmcloud.com, there's a Slack. We do community meetings on Wednesday. There's YouTube channels with a couple of years of meetings on it. And it's generally a pretty friendly community. In fact, our meeting is at 1 o'clock today, right after this meeting, if anybody wants to hop on and join. Now, WebAssembly, as we mentioned earlier, was just a CPU. So there's a standard that's called WASI, the WebAssembly System Interface, that lets us define building blocks. And these building blocks are organized into things that are called worlds. So if we look at, I want to pull up some worlds here. If we look at, let's see here. Well, I don't have any up right now, but essentially worlds are collections of interfaces. So there's a world that's called WASI CLI, and that gives you the ability, and that includes things like I/O and sockets and clocks and things like that. But these standards are becoming building blocks that we call the WebAssembly component model. And the neat thing about components is that these contracts or APIs are defined and standardized, and the components that you use to deliver them can be implemented in multiple languages or even with different implementation types. Because WebAssembly is a sandbox, you're oftentimes implementing a contract like WASI SQL might have a plugin for MySQL, for Postgres, or for Azure Cosmos DB. Those are example components that come in wasmCloud, and you can then hot swap between those without updating your application. So what we're trying to do is to address this compile time problem that containers suffer from. When we build containers, we actually take all of their dependencies, their non-functional requirements, and we embed them at compile time. What WebAssembly enables to do is to load these various dependencies at runtime. And what that means is that platforms can load the most recent version at runtime, giving you the latest, most up-to-date version. So you're not embedding vulnerabilities. Thank you, Kate, for putting the WASI CLI link into chat there. So the WebAssembly component model is standardized by the WebAssembly working group, and it supports these high-level types like strings and records and variants, things that WebAssembly as a little virtual CPU that takes numbers in and numbers out does not support. And what it gives you the ability to do then is to import other modules. So I can say at runtime that I want to import the Lego block for logging, and I want to import the Lego block for errors, and I want to import the Lego block for OpenTelemetry, and then I can use those building blocks to compose my application. And remember, those blocks can be made in different languages. So users could program in Python, for example, and they could leverage components that are performant and written in Rust. And these APIs are described using a language that's called WIT, WebAssembly Interface Types. So you start with your API declaration, and then they're pluggable from there. Now, I'm going to take a quick diversion here into the WebAssembly roadmap, which was just published by Bailey Hayes. Bailey is a director at Cosmonic, and she is also the user developer, or the developer representative to the board of directors of the Bytecode Alliance. So we just published this 3-tier roadmap that I can point you at. There's a great blog here on the Bytecode Alliance website if you'd like to take a look at this. There's a narrated YouTube overview. And what this aims to do is to take you into all of these various standards here and make some sense about how they all fit together. There are changes that are upcoming to the core WebAssembly runtime. So think of that as like the CPU, to the component model, which are those pluggable blocks, and even to WASI in the frame of defined blocks that we're running using the component model on top of core WebAssembly here. And there are what's neat about the way that this has been organized as an ecosystem is that this is really a better together move. If we think of WebAssembly components as the sort of new as the new container, the new abstraction, components can be created by common language tooling and then be used to create other components. But what's neat about these components is that just as containers were portable across different runtimes and implementations, components are also portable across different runtimes and implementations. So if you're building components for CNCF wasmCloud, those components could work, for example, at Kate Goldenring's company, which is a Fermion. They have an open source runtime called Spin, or they could work and theoretically even on other WebAssembly users such as Fastly or Cloudflare, who are using WebAssembly to deliver their experiences. Without speaking to their product roadmaps, that's the intention of where we're going with these components. So these WebAssembly components are portable, they're pluggable, and they run everywhere and can be made from different languages, as well as linked together. So building applications now becomes this effort in just giving developers the smallest piece of code to work on as possible. So what I'd like to do is go through a couple of abstractions about what wasmCloud enables using these, and how you can now build your applications using these pluggable components. You could create an application here, this one that's just called Ping Pong, where you can swap between Redis and a built-in key value store, for example. Or you could hot swap in something that also matches that contract for messaging, such as HashiCorp Vault for secure authentication. It abstracts the topology of the application from the implementation of the application is what we're doing with linking. And this has profound impacts on cloud native if we can adopt this technology. One of the massive problems that we suffer from today are by embedding vulnerabilities across hundreds of applications or thousands of applications in an enterprise. When there are vulnerabilities in core components that are compiled into every app like Log4j, all X teams need to stop and patch those vulnerabilities. And there are many techniques to try to automate that. But imagine a world where we can, instead of having 5,000 teams patch 5,000 apps, where we can have one team patch one component that then is adopted and pulled in at runtime. This is a huge opportunity for cloud native and was the primary reason that I saw this as the biggest opportunity in tech, the most common complexity that we were looking to abstract away from. Now, I don't think that it's fair to compare and say that this conversation is, excuse me, WebAssembly components versus containers. In the same way that it's not fair to compare containers to virtual machines or virtual machines to real hardware. These things all work together in and around cloud native, and they essentially offer you different value propositions for where they can go, what capabilities they have, how reusable are they. So just to do a quick comparison between containers and WebAssembly components, components are compatible with everything that came before. There are multiple ways to run components in WebAssembly on top of Kubernetes. You can put it inside of a container. There's even a native implementation that's looking to try to orchestrate a WebAssembly directly in Kubernetes. or things like wasmCloud allow you to run on Kubernetes or directly on tiny edge devices, which is where we brought that up in this particular conversation. Now, one of the advantages to containers is that we were able to lift and shift most of our applications right from Linux and just put them in a container and run them on someone else's application. While that can sometimes happen with WebAssembly and components, I view WebAssembly and components as more of a greenfield, where you're building new applications and able to bring in libraries and frameworks, but oftentimes you're thinking about how to re-architect to take best advantage of the unique properties of WebAssembly that we have here. So what does wasmCloud really bring to WebAssembly? What wasmCloud gives you is not only a developer experience around starting, running, managing, and stopping these things, but it also introduces the sort of common components that we think enterprises want. So wasmCloud signs all the WebAssembly artifacts, it signs the invocation request, and it enables you to invoke and operate WebAssembly modules across disparate infrastructure. Underneath the hood, it simply embeds NATs. But from a user point of view, it means that you can use capabilities regardless of whether running in a adjacent WebAssembly module or not. And this is very powerful because it suddenly means that you can build applications that are self-forming, that are self-healing, that run across clouds or edges, all without modifying your applications. So it's we view wasmCloud as distributed WebAssembly. And the reason why we think that's important is any application that matters is going to have properties like highly available, reliable, and in wasmCloud, these become knobs that you can turn, which we'll see in the demo. Now, underneath the hood, WebAssembly, wasmCloud uses a manifest that uses OAM to define an application. Let me pull up an example here. So if we look at an example OAM manifest, this will look very familiar to Kubernetes people. You can define an application with a version and then describe the WebAssembly components that you want to use to pull these together. And a WebAssembly component can have requirements. So here we have components that have requirements on SQL, for example. And I can say that I want to also load the Postgres module. And then here I'm giving a manual definition for what is the link definition for that particular module. Where does that component connect to? But these could be loaded into stores as well, just like you can with Kubernetes. This is supposed to be a simple example. And then common components like web servers and database components can then be loaded. Underneath the hood, these components live in OCI, just like we do with containers. And we work very closely with Docker and with Microsoft and other cloud providers who are aligned and participants in the greater WebAssembly ecosystem to ensure this better together experience. If I could describe the relationship between cloud native and WebAssembly as a whole, it's very collaborative, and we really aim to be this better together type experience. So where do we end up with what wasmCloud brings to WebAssembly? And then I'll pause and we can do some examples. Is wasmCloud aims to give you orchestrated WebAssembly that runs on any cloud or edge. And in the demos that we're going to do here shortly, we're going to spin up wasmCloud running across multiple clouds, across multiple edges, including my laptop here. I'm actually in Michigan right now. My power is out at my house. So I'm at my neighbor's house on their Wi-Fi that I've never been on before. And we're even going to spin up modules here remotely on my MacBook and build applications with these Lego blocks that are running all around the world. Let me pause for a second, solicit some questions, and then we'll go from here. I see a couple questions in the chat. Liam, are those declarative links of components discoverable by a user for security scanning? Yes, there's multiple ways that you can discover them. Essentially, when we're building and running applications, one, you have your YAML that you have when you're bringing in your apps. And so you have the ability to pull them down and orchestrate them at that time. And the second thing is that In wasmCloud, we run what are called lattices. And a lattice is essentially a flattened topology for an application. And you can have multiple lattices that each are scoped to their own unique permissions domain. So think of them, very similar to what you might have with pods on Kubernetes. Did that answer your question, Kate?
I was just providing more context for the answer to just talking about how components are linked explicitly across interfaces. And so you can understand basically what your single WASM file is built out of by extracting the interfaces that it consists of.
Yes, WASM itself is similar to plain text. So there are multiple tools. There's a great tool called XDism and some other things in the ecosystem that allow you to scan WebAssembly modules and even see does this consist of other components, because it can be turtles all the way down. You can have components and components. Victor asked the question, does the Cosmonic control plane run on Kubernetes? Cosmonic itself as a company does not run on top of Kubernetes for our backend. We actually use a Hashi Nomad in order to orchestrate and run our WebAssembly. And we just released a very popular plugin that brings Cilium to that ecosystem and that world called NetReap, which is a command that lets you use Cilium and all the amazing stuff that you can do with eBPF outside of Kubernetes. Now, we are compatible with Kubernetes. You can, on wasmCloud, we actually ship a Helm chart that you can spin up that will deploy wasmCloud across a Kubernetes cluster. And within Cosmonic itself, there's an even easier way to do that. What Cosmonic aims to provide is orchestrated WebAssembly, and that's the company I work for. Question, are there tools planned to manage the WASM components? It feels like it can become a dependency management nightmare soon. Absolutely, there are tools to manage WebAssembly components. And when we look at the roadmap for WebAssembly itself, there's actually a whole registry that gives you supplemental information about components. This registry is called WARG. There is an early version of it. What WARG provides is component metadata. So you can query it and say, give me all of the components that match WASI-SQL. And it has a labeling system, so you could even query for other additional properties, similar to how you can query for containers. And the underlying storage for those is on OCI. Shan, I would actually push back a little bit on the dependency nightmare here. And let me share my experience. When I was working at Capital One, this was what I decided was our biggest problem in tech. I got promoted as VP of Innovation. I own the open source office, and my boss said, "Congratulations, you have 1 million vulnerabilities." It wasn't that number, but it was a really large number. And when I dug into that problem, I couldn't believe it. And what the sort of source of the problem was that we tried to bootstrap our developer experience by giving them a golden template. And this golden template was a great way to get started. And it essentially was an application template that had all of the enterprise goo that we needed in order to build, run, and scale our applications. Logging, metrics, open telemetry, all of those things. But as we distributed that across thousands of applications, we were really suffering from multiple problems. We had some ability to auto patch and auto upgrade people, but essentially the developers would typically need to get in the loop to patch things like Log4j. So by distributing unique copies of each app, we essentially created a bigger nightmare than the ability to centrally manage individual components. And I see this as the sort of goal of organizations that are adopting things like service mesh or platform engineering. Those are really just ideas about how do we reduce the service weight, how do we pull common components out of applications and put them on a third rail? And ultimately, how do we give developers an experience where they're writing as little code as possible? That I think is the real goal for what we want. And when we look at how Cloudflare and Fastly or platform engineering really embrace is they try to let the platform provide the latest copies of everything at runtime versus compile time. And WebAssembly has some unique properties that I think make this even better. WebAssembly is so small that it has a cold start time that's oftentimes measured in milliseconds. Kate, you gave that awesome talk at KubeCon EU, WASM Day, where you scaled to 10,000 WebAssembly modules in just a few seconds. Is that right? Yeah, it was a great talk. If you'd like to see the implications of that, what that means is that you can think about starting your WebAssembly modules per invocation versus having a bunch of warm containers or a bunch of warm lambdas here waiting to service requests. Shan, did I answer your question or maybe speak to your topic of dependencies?
Absolutely. Thanks a lot.
Great question, by the way. Thank you. So I'm going to do some demos here that I hope are a little interactive. And I'm actually going to use Cosmonic to run them, which is our commercial platform for the company that I work for. Everything I'm doing is compatible with wasmCloud underneath the hood. And what Cosmonic does is just gives you the batteries included experience. So I'll try to draw out the differences here. So this UI is what comes with our product. The wasmCloud is, command line and via YAML. But I want to be able to help people visualize what's happening underneath the hood here with a few simple apps. So here I've got an app that is very simple. It's an XKCD generator. And if people on the call will maybe grab your phones and spin this up, we're going to use wasmCloud to run this application across disparate infrastructure, including Kubernetes, all without modifying it very quickly. So if anybody has that up, maybe give me a thumbs up or an OK in chat to play along here. You can just hit this QR code on your phone, and you should just get a random XKCD. Okay, I think somebody has it. So what I'm going to do is I'm simply just going to delete this. Now, underneath the hood, this is not being managed. Kubernetes, or just like Kubernetes, wasmCloud does support reconciliation controllers, so you can sort of manage state. And if you refresh your screen, your app should now be broken. You should get a Cloudflare app. So Alex, if you just pull down, that should fail for you. Now, let me show you the infrastructure that I've spun up here before our meeting. What I did is I went ahead and spun up wasmCloud running on different operating systems and in different clouds running all across the country. So here I've got this host called Bouncing Rain that's running on my local MacBook. I've got a host in Microsoft Azure running on x86 Linux down in Texas. I've got a host on Oracle Cloud that is running on virtual ARM64. I've got a couple Kubernetes nodes here in the middle that are running on a Kubernetes cluster. I've got a host running on Cosmonic Cloud in AWS East, and I've got a host running, another host here running on my local MacBook, and this is also on my MacBook here. Now, to spin these up in wasmCloud, you would have to run NATS yourself centrally, and then spin up wasmCloud and point them at NATS, and then you would have all these things working in the open source. Cosmonic makes that a little bit easier. But we can easily spin up our applications using wasmCloud on any cloud or edge. So here, if somebody wants to just chime in, we can use labels in order to schedule this. I'll maybe run this on Oracle Cloud. Somebody wants me to run it anywhere different, I can go ahead and do that. And now we've spun this up on Oracle, and if we refresh our app, things should work. Now, that's great, but what if we wanted more availability or more reliability? We could take this Bouncing Rain host, which is where I'm sitting in Michigan today in Traverse City. I'm actually right here at the end of this peninsula, surrounded by all these orchards and vineyards and all that. It's actually quite lovely, except I have no power today, which is sad. And let's spin it up here on Bouncing Rain as well. And then we'll start deleting hosts, and we'll show that the application just automatically self-forms and self-heals across NATS here. So I'm doing this manually, but normally I would do this with a YAML spec. And that was, what was that? Was that Bouncing Rain? Was that my local host? I don't even remember. It matters and it doesn't matter. But now what'll happen underneath the hood is NATS will route these requests to the closest matching provider. And if I were to come into my infrastructure and delete that Bouncing Rain host, even without making any changes, this application just self-forms and self-heals. So underneath the hood, this is an abstraction that wasmCloud provides that lifts us a bit higher than what we find in Kubernetes. And that's the goal. It's to take the common complexity of application libraries and enable that to be the platform that we're building on itself. And our ecosystem has really blossomed, not just WebAssembly, but wasmCloud in particular. I'm going to do maybe one more demo. I could hot swap components, but I want to make sure we leave time for questions around distributed ML, which is what drove this particular question. And here what I'm doing is I've got a simple application that's running a web server that could run on any of those nodes. It's got a neat little or basic little UI that I can upload pictures to. And then this application can route to different machine learning models depending on if I care about privacy, performance, availability, regulatory domain, or whatever the case would be. Now, if you're not familiar with how machine learning models work, essentially what happens is images need to come in and get processed, and that basically will take a raw image and then size it to the vector, first take the image and standardize it so that it matches what the machine learning model's been trained on. So that could be size, color balance, number of bit depth, all of those sorts of properties. And then it essentially turns it into an output vector. This output vector has a neat property to it. If we think of this raw image as being a meg, these vectors are typically much smaller than that. So there is a measure of compression that's happening here. So if we are running these preprocessors on the edge, we have the ability to minimize our ingress-egress charges and increase performance as we move these things around. We can also run our machine learning models in places to protect privacy or in places to respect regulatory domain, for example, around what data can move in and out of countries. All right, so enough talking. Let's just do the demo here. So the two models I'm running here are ResNet and MobileNet. And we use wasmCloud, wasnNN, which is one of those standards that supports Onyx, TensorFlow, or even Intel standard OpenView. I can't remember what their machine learning standard is off the top of my head. And I can sort of submit multiple pictures to it. And because I'm using this lightweight mobile model that's measured in megabytes, I get maybe a lack of fidelity in my results here. This espresso by MobileNet is only 84% identified as espresso. But I could submit a picture of a hot dog, and it's pretty sure it's a hot dog. I could submit maybe a cute little kitten, and it thinks it's a 44% tiger. Now, if I wanted more accuracy, I could submit this to a ResNet, which is a larger model that's around 250 megabytes. And now the model will route those same requests to the higher fidelity model. So here, espresso is labeled as 99.5% espresso. And what's powerful is these various components can live on different size devices. So we could run just the preprocessor on the edge device, which would then just ship the smaller vector to the machine learning inference API, and then return results. So the distributed properties of wasmCloud mean that your basic application topology can have radically different implementations. I could develop as everything running on my MacBook. Without changing my code, I can simply deploy this across multiple clouds. Without changing any of my code, I could run this across multiple edges, different operating systems, different CPUs. And the sort of end result that we're really aiming for is this experience where developers can write the smallest piece of code possible and then operate it across any infrastructure. Shanna, a great question. What's the typical size of a WebAssembly module in production? Similarly, what is the size of application that have all things WASM, components, worlds, modules? I see value in reduced and air-gapped environments, such as OTA, if a WASM module exists. So I want to first say there are multiple companies that have a vast array of approaches to running WebAssembly on the edge. There are companies that just give you an edge native experience. There's companies that talk about WebAssembly. There's companies that are really focused on a great use case, like FAS, for example. But let me speak to your question. A bit of what shapes the size of the WebAssembly module is the language that you start with. Some of the interpreted languages like JavaScript or the current approach to Python and Go bring measures of either their interpreter or their garbage collector into WebAssembly. Go support just launched this month, for example, and it brings its own.
I think we lost Liam.
The gremlins have gotten to his electricity.
Hopefully he comes back. It was just at a real interesting.
If
Yeah, this is
only
shit.
Liam was a WebAssembly module, we could just distribute him to another computer and be all set.
Well, he said he had no power where he was at, so
Yeah.
maybe the battery ran out. If anybody else here on the call, I think we have some WebAssembly authorities. Feel free to jump in while we're waiting. Oh, there's Leon's video.
Hey, sorry,
Okay, we got
power
you.
went
We
out
can
at
hear.
this house now. Power went out at this house. So my apologies here. Let me share my screen. I think I dropped when I was answering Shan, your question around the size of WebAssembly modules. Is where I dropped out?
Yeah,
Yeah,
it was
you-
just when you were covering that it matters which language you're using, and you started talking about memory garbage collection, and then you dropped.
Yep. So different languages will result in different sized WebAssembly modules due to how those languages work. So static languages like C, C++, and Rust tend to produce WebAssembly modules that are very tiny. Languages like .NET, Go, and Python produce modules that are a little bit larger because they bring the interpreter or the garbage collector with them. We published a case study with Adobe where we went through an example where Adobe was running some containerized Java that they re-implemented in Rust. And what's powerful about this particular demo is the applications were good. In wasmCloud, they were the same algorithm. They were really tiny. They went from consuming 2 gig of memory per instance down to something like 150 kilobytes per instance. And they were so small that they could even be operated sometimes within the in the user's browser. So they were not only good, but they were fast and cheap here. And what that meant was, in most cases, instead of uploading these images that then have the background removed to the cloud, and egress and waiting the 450 milliseconds for that to happen, all of this work could take place right in the customer's browser. And that meant that it took place in 40 milliseconds, and Adobe was just paying for the loading the module in the customer's browser versus pulling all the megabytes of images up that needed to have their background removed. It's a powerful use case. So I think to make sure that I circle and answer your question is, the size of the WebAssembly module depends on the source language and the frameworks that are compiled in there. But generally, it is orders of magnitude smaller than what we find in a containerized world. And that's typically because even with containers, it's very rare that people are doing from scratch, like with Go or something. Shan, did I answer your question?
Yeah, in a way, that's I think it makes sense now. One related question to that was, so there's no concept of having like the OTA part, right? I was curious about if there are things out there where people can, you could just ship out an OTA WASM module somewhere over the air to a very remote device that's supposed to do this, or maybe the same point where you mentioned like I'm patching the logging component, WASM component or something, and I don't have the, let's say, the luxury of being connected to a centralized registry or something. So assuming if the modules are small enough, are there some specs out there where it can be like a well-suited solution for over-the-air stuff?
Yeah, so wasmCloud does let you do inline updates via NATs. So you can update components that way. And you can even switch to different implementations of those components. But there are, I think, emerging standards here to bring that into WebAssembly generally. One of the standards that I would point at is the standard that's called WebAssembly Vert, which allows you to virtualize resources. But at the WebAssembly layer, we're primarily dealing with the, the standards, and then the developer experience kind of moves out to the different open source projects like wasmCloud or wasmEdge or Spin, and those ecosystems to manage it. Frank, you asked a great question around on the AI/ML example, can you make use of the GPU capabilities? Absolutely. One of the, I think, neat properties of wasmCloud is we enable you to load components that are external to WebAssembly. So if we think about WebAssembly as this tiny virtual machine, it doesn't have support yet GPU extensions. So one of the properties that we do support, though, is you can load an external provider. So on our example that we did here, let me switch back. ML interface provider here has a component that runs externally on my MacBook, the GPU. We have examples in previous KubeCons where we spin that up using TensorFlow and the GPU on the device. We think that is one of all options that you would like. Now, that is supported by the component model. The component model lets you run capabilities that are local to a runtime that are included in a device or in a WebAssembly runtime like wasmTime. Can be loaded externally by a framework, or in our case, we choose to load it outside of NAS. It's probably a bit beyond this discussion, but TLDR, yes. Kate, for runtime deployments using the late bindings of dependencies, are people exploring the potential of doing this in air-gap scenario, which is sometimes useful in certain edge use cases? Yes, we have many customers in the wasmCloud ecosystem that specifically do use us in air-gapped situations. You obviously run into the challenges of how do I update that air-gapped system. The powerful thing about how wasmCloud works, though, is because the components are distributed here, you have the ability to download components across this lattice that is running underneath the hood here. So you have the ability to download them here across NATs to support the concept of a distributed application. And we do have a couple customers that have worked with the open source community on making sure that that is reliable and available because they depend on that. These are great questions, and I know I'm at time. So I would encourage anyone that's interested to please join us on our wasmCloud community call. It's actually at 1 o'clock right after here. Or I'll put links to our Slack next door. It's a really fun and engaging community. WasmCon, which is September 6th and 7th in Bellevue, Washington. The Bytecode Alliance is holding a hackathon called Bacon right after that. Actually, it's called Compress the World. I call it Bacon for the Bytecode Alliance Con. And then we'll, of course, I'll be at KCD DC if you're in the Washington, DC area. And then, of course, we'll be at KubeCon, and I'm co-chair of Wasm Day as well. So there's lots of opportunities to come meet us, and there'll be a wasmCloud project booth at KubeCon that's staffed all day as well. I really appreciate the time, and feel free to hit me offline if you have any questions or any follow-ups.
Okay, thanks a lot, Liam. That was a great presentation, and I'm impressed at how much you covered in a small amount of time.
I need a drink of water, but it is a whole ecosystem in and beyond itself. And there's a huge contingent of us that really believe in the better together story.
And then Joe Biden became president of the United States and launched his war on energy. Since that time,
thank you. There's a whole community of us that work really hard on the better together story. WebAssembly is compatible with, run where you support you wherever.
Liam, your audio is getting choppy, so maybe something's happening. But thanks if you end up dropping again. Okay, next on the agenda, we had some discussion of forwarding the cloud native white paper and coming up with a plan to build awareness of it, perhaps using the KubeCon North America event. Andy, I think you put this on the agenda. If you're available, I made you a co-host, and as a backup, if Andy was having connect difficulties, I guess I'll also make Brandon a co-host, because I think you were one of the people driving this effort as well.
Hey, Steve. Thanks. So I think, yeah, it's pretty straightforward. We'd like to have a forum somewhere out there in KubeCon North America to be able to publicize the work that we've been doing in cloud native applications. And so I think we went back and forth a few times on some possibilities. There's some places either in intros or outros where there could be mention of the project or of the particulars of the interaction we've had. And so those things seem amenable. And if there's any other places where we could do some kind of short intro, that would be fantastic too. I don't know that anybody wants to sit necessarily and hear us drone on about what are the exact principles, but I think giving some awareness as to, hey, this is the next tranche of guidelines coming out of the IoT Edge, that would be fantastic.
Yeah. So I think there's two elements involved here. Right now, this thing is still kind of in discussion draft stage. Not that that's a problem, but we really need to aspire to have this be wrapped up and published by the time of KubeCon, because I think it's a lot better to promote it as kind of a published, already reviewed document than still saying it's a work in progress. So let's try to push this forward. I know we aspired to even having it done now, but a lot of valid comments came up, and I think there's maybe just a little bit of work to do. Number two, in terms of promotion, the opportunity to get a maintainer track session or even a session at the Kubernetes on the Edge Day event has passed. I don't want to cheat on the rules and slip it in there when everybody else has to abide by the rules. But the opportunity we have to put it in there regardless, that I can't promise, but the organizers of that event have always allowed for an opening keynote as well as a closing address. I think the closing address always has had where to go to learn more, where we talk about this group, and it would be a natural fit there. But until the actual speaker is appointed to deliver the closing address, I don't feel comfortable in absentia cramming it down some yet to be determined speaker's throat. It's up to them, since they have to deliver it, to, keep it in their own voice. But I'd really be pretty confident that whoever that speaker is would be happy to put, a minute of slides in that address. Maybe you could get 1 to 3 slides that would summarize it. I think what you really want to do is maybe have a slide more or less trying to describe what it is and what it isn't, and then give them a link to where to find it rather than to re-deliver the whole white paper. I mean,
Right.
If the white paper could be done in one slide, you don't need a white paper, but
Right.
it's bigger than
No,
that.
I mean, so Steve, I want to be clear and state some facts. One, we've been bringing this up to the IoT Edge here collectively for several weeks now. So, I can't push any more than what we've already done. So the fact that we missed some deadlines, nothing really I can do with that. I've attempted to do it, right? So within the confines of this meeting. The second thing is, yes, I agree. I don't want to recapitulate all the data and information that's inside that paper. It would be sufficient to have some high level understanding of what the paper espouses to do, to guide people on, and leave it at that and open it for more, more interaction post the conference, right? So lastly, the restrictions on how many presentations one can give at KubeCon are nothing that we can control. So of which I know that at least Frank and I are kind of fully booked at this point at the 2 presentation limit. So it would have to be, some other method of delivery, probably not by either of us. And I think that that exit discussion or the closing remarks would be a good place for it. So that's where I would go. Kate,
I think we'll have that established in a month. So,
Hmm.
At that time, we should have the accepted session list for the Kubernetes on the Edge Day. as well as identification of the closing speaker. And we should be able to get this resolved in about a month.
Okay. Kate, you had a question?
I just had a comment. The runtime tag, they had their monthly meeting and was asking for a status update. And I was telling about the progress of the paper, and they said that they would appreciate if we kind of change our way of work to have GitHub issues for each major thing we're working on. So just was a call of action for maybe Andy or Frank, or I'd be willing to put it up for us to put up a GitHub issue. And that basically says, like, this is the white paper we're working on. Here is the Google document with the draft. And then we can kind of have subtasks, maybe like Brandon, you've done a really good job of working with the CNCF marketing team to get that into a published state. So that could be a call to action. And yes, it is disappointing that we didn't get it into a presentable form for KubeCon, but having a published paper might be something that we can then transfer our energies to. And then maybe for the next KubeCon, it would be cool to have a talk that not only presents the content, but also gives that demonstration of an application using these principles to kind of really land it.
Yeah, well, so I would respond to that. So yes, I can take the ownership of building a GitHub issue. I think much the same, it was my expectation that much the same as many of the presentations that we put together for KubeCon or any other conference is that you wait for the opportunity to be accepted and then put together the materials to back that up. So I was completely unaware that we had to have a completed certified bona fide paper before we could apply for a presentation slot. Is that the statement that you're making?
Not at all. No, I'm just trying to put a silver lining on things of saying, we maybe can put effort towards getting that published version and focusing our efforts there instead of splitting it into presentation and getting the published paper out. But no, last time we certainly didn't have it completed before the conference. So I would not say that is the standard.
Okay.
Maybe a question to Brendan, real quick, if I can go and chime in. Brendan, how long does it take to go and process the thing? So if we assume that we would wrap it up in the next 2 weeks, say, how long would it take to go and do the processing, the beautification, to go and ultimately get it published as a PDF?
Can vary, but I would say on average 3 to 4 weeks. The pipeline of the creative services team is generally pretty full, and so when just using last time as a benchmark, it was about 3-4 weeks at that point. I also, just more history on the last one, we did have it in near final draft state, I think, ahead of the last event where we presented it, and it did make it in as a talk around the topic, and part of the kind of the call to action afterwards and linking to the paper was, this is here, we'd love your input, come read it and give us that feedback. We allowed a certain amount of time for that to come in, and then we felt good about hitting the finalize button from there. Pros and cons of making it final sooner rather than later and waiting, that's maybe something for us to figure out, but definitely there's still an opportunity to share this goodness with the community and build on it from here.
Yeah, so we can have a final or a near final draft that we would put together for the conference, ask for feedback, and then wrap it up after the conference, right? So that could be a means of operation.
Yeah, that's kind of more of the workflow that I thought it was going to take on, because what would have been the point to invite somebody if it was already stamped?
Yeah, so that we have a broader
Fully
audience, even broader than here, get more feedback in, and then do a second round until we really call it final.
Yeah, that's probably what I'd recommend.
Yeah, just to jump in, Andy, I don't think that any of the co-located days count in your 2 presentations for the limit for KubeCon. At least I've been a reviewer for WebAssembly Day for multiple years now, and other areas before that. And there's not even a mechanism where we see a KubeCon submissions from the perspective of a day.
Well, that's good to know. So I
You
guess
really
I was,
wanted to
I guess
get
I
it
was
in.
misinformed. I don't know what else to do there. Yeah.
I think he froze up again. So I think the point there was the day zero events are somewhat separate from the conference. And might there be an opportunity like in one of those to think about some kind of features as well. I think this group more or less is a lot of the same people that plans the Kubernetes on Edge Day. Is that right? Would that same criteria apply to that event?
Yeah, I think that I'm aware of 3 people active in this group who are on the program committee for Kubernetes on Edge Day.
Mm-hmm.
So we don't control it per se. It's run by CNCF organizers, but
Right.
we're the ones who volunteer to review CFPs.
Okay.
So I mean, I'm sorry. I know I'm coming off this way, but that's my intent. I'm a little bit frustrated. I mean, I'm not going to do the spilt milk thing. I'll just make mention of it. We've been bringing this up for several weeks and we've hit numerous barriers. And now this information comes to light that it wouldn't have been a barrier. I'm confused, I don't think this is in a state that it can't be released to the public and people can have a chance to review it. So that's first. And second, if we could have had the opportunity to do it, we should have. And I just don't know why we waited. That's all.
So it sounds like there's clear frustration about a lack of facilitation from the maintainers of this working group in getting this talk as our maintainer track talk for this working group. And that's something that clearly fell through the cracks. I've been out a lot of the summer, so I wasn't at the past several meetings to initiate that. So if you want acknowledgement of that, then I'll acknowledge that I didn't help move that forward. The fact that Edge Day submissions,
that's all. I don't put.
no, that's fine.
Yeah.
And the fact that Edge Day submissions have been open and maybe not, we've been publicizing them in the working group, saying that those CFPs have been open, but I don't think we've been so focused on the maintainer track opportunity that we didn't focus enough on this being an opportunity for an Edge Day submission. So that's something that we can kind of be sure to evangelize more in the working group, is that this working group, when it's opportunities for speaking come, it's not just for a maintainer track session, but it's also for those Edge Day submissions and helping facilitate those happen. So I think we can definitely do a better job of that. I'll personally try and do a better job of that, of trying to create opportunities in this working group to present at Edge Days and reminding people of that. But yeah, it's clear that we are a little frustrated of not having participated at that level with KubeCon.
Yeah, the other thing I'll say is,
in
terms of the rules of how many talks you get in things, we don't make the rules. And frankly, I don't want to spend a lot of time even publishing them. The CNCF makes them and they have them on the conference
stated that they
websites.
don't apply. That's the issue that I'm bringing up here. It just was stated by, I think Brandon brought it up, that they don't apply. No, not by Brandon, by Liam. That a day does not conflict with the requirements.
Like I will also say this, Andy, it's that I think that there has been, we're all volunteers, and I don't think that oftentimes it's that we maybe get communicated the same set of rules. And I hear that the frustration in that. I felt that as somebody that volunteers to run a day, and that's a different day than the day that Steve is working on. So maybe Steve's team was told that it does apply. When we asked, we were told they didn't think it applied. But I understand that this is all contextual, and I also always believe in positive intent. And I know everybody is doing the best they can to try to embrace the better together positivity of the CNCF and the community aspect and move forward. I've always found a lot of flexibility.
Don't misinterpret my comments. My comments are surely this, is that they're just based on, what's been going on, the workflow, the factual day by day, week by week. And that it's a retrospect, if anything. And listen, I receive this all the time from my open source community, right? On occasion when things happen. So all it is a reflection, and I'm not walking away from here punching a wall. It's not happening, So
yeah, and
it's just me bringing it up. That's it.
Yeah, I'm happy to hear.
Let's try to go and be kind of. Let's try to go and fix it next time.
Yeah, let's fix it.
Let's look forward.
Here's an idea.
What I would appreciate is that we wrap up the paper as the kind of draft version 1, in the next 2 weeks. So everybody, please go and throw in your comments. We'll go get them in so that we have a version for pre-publishment ready for Brendan to process, and we can go and progress that way. So I think then at least we have something out, and we can at least see, like maybe in the closing note, we can go and have a reference so that people throw in their additional comments. So maybe we can go and progress that way and acknowledge the frustration, but well, take on the next steps despite of that.
Sounds good.
Here's an idea if you wanted a forum at the event. It is sort of running a sidebar thing. But in the past at KubeCons, we've had physical working group meet and greets where the idea was that if there's a number of people from this group who are maybe even just casual people interested in the general topic, that we just declare a meeting place, like some bar or restaurant, you know, in this case in Chicago, and just meet there. And I'd say about 2/3 of the time we had some corporate sponsor stand up and pick up the tab, or a couple of them pick up the tab, but sometimes even that didn't happen and everybody's on their own. But I found those historically to be quite useful, where, you know, you sort of enjoy meeting people on these Zooms, but it's a little different from a physical meeting. And if a number of us are physically giving talks at KubeCon North America, we could have such an event and present on the white paper at this venue. We've done that before too. I think the original one was the original unveiling of CubeEdge happened at one of these. And at the time, Huawei was the one who sponsored the event. But whether we get a sponsor or not, I think we could do that and publish this going into KubeCon, and maybe build a, you know, we've had audiences that are up in the range of 30 some people at past KubeCons, which, you know, isn't bad for a specialized interest area.
Yeah, do we know where the conference is being held and what facility?
It's the McCormick Place or Center in Chicago, first week of November.
Yeah, I just didn't know the venue. Yeah, I could have looked at. Okay, all right. Yeah,
It's basically downtown Chicago, so there should be plenty of opportunities to just pick an ad hoc place to have, you know, an informal meeting. It wouldn't appear on the official KubeCon schedule, but I think that we can get out word, and we could mention it during Kubernetes on Edge Day and a few other times so that people are aware that it exists.
Yeah, I was just there 4 weeks ago, so I'm really familiar with the area, and I'm sure a lot of people here have traveled there recently too. So I'd be comfortable with that as an option. I think it's also good, as you know, honorable mention in the closing as well. I mean, again, the goal is to just get the final polish on the paper, I think.
Yeah.
And I think Frank brings up, you know, we'll drive it to as best we can, complete what we can do up in the next 2 weeks. And then we'll hope that we can get some support from the working group here to see if there's what avenues would be the best ones to land it in. Would that be all right?
Sounds good to me.
Okay, cool.
Okay, we're at time, so let's call this meeting to a close. We'll have another meeting in 2 weeks. I think the agenda is still, well, it isn't even in the agenda notes doc, but if anybody wants to put something on there, I'll open a space in the agenda notes doc for it. And as usual, members can just self-nominate for topics they want to cover. If we're trying to close out this document, that sounds like a worthy thing to put on the agenda. And maybe we could even aspire to having it done there. I won't be available for the meeting in 2 weeks, but I think Kate has said that she thinks she will be. So we'll see you in a couple of weeks. Thanks for coming, everybody. Thanks, Liam, for presenting. Thanks, Andy.
Thank you. You guys in 2 weeks.